Example 3, multiple representations of polar coordinates. Part A asks us to find 4 different pairs of polar coordinates that name the points S as shown here on this graph. Now, we want to keep the angles between negative 360 and 360. So when we go about doing this, the most obvious way for most people when they see this point to label it is to count how many circles out, as it's 2 circles out. So they would say that S has the point 2 circles out, that's what the R represents here, and the angle that it's on, the pole that it's on, if you will, is 210 degrees. And this is correct. That is one way of listing what that angle S, how to represent it. That is one way in polar coordinates. Now, every polar point can be actually listed in 4 different ways. That's the obvious way. So how do we find the others? Well, the answer is you either add or subtract 180 or pi, depending on the units. So I'll write it over here. You add or subtract 180 degrees if you're working in degrees, or pi if you're in radians. Since this is in degrees, we're adding and subtracting 180. I'm just going to subtract 180 here. And when I do so, I get the second way I can write the point. As I'm going to have 30 degrees here. Now here's the deal. Whenever you do a 180, if you think about driving, if someone says, hey, bust a 180, what they're talking about is change your direction. Now, if you change your direction, you're no longer heading 2 circles towards it. You're now heading away from it. And so what we do is if you bust a 180, you must change your direction from positive to negative or vice versa. So the second way of writing this point would be with a negative R value and with the angle of 30 degrees. This means if you look at 30 degrees, you go 2 circles away from it. Let's check it out. I meant to write a 2 here. I'm sorry. Let me correct that. So this is saying if you look at 30 degrees, which is right here, this pole, you go 2 circles away from it. And so that'd be 1, 2, and we're still there. So we've done it correctly so far. Now let's get to the third. The progression is the same. I'm just going to subtract 180. And again, if I bust a U, my direction changes. So no longer am I going away. I'm now returning towards the angle. And 30 minus 180 is negative 150. Now let me interpret this one for you. This is our third way of writing the point. This means a negative degree means if I go down this direction for 150 degrees, I should get to this pole here, and I would go 2 units towards it. Now, a full circle is 360. So if 360 is all the way around, and you took away 150, meaning we're going backwards, 360 minus 250 is the 210. So we did see that it is, in fact, the right location. And to find our fourth point, I just do it one more time. Same concept. Subtract 180. My radius, if you will, my R value will change from positive to negative because I'm switching directions. Negative 150 minus 180 more is negative 330 degrees. And those are my 4 points. Now, this one worked easy because I could just subtract 180 every time. I'm going to return up to the instructions. It says keep the angles between negative 360 and positive 360, which in practical purposes, that means you're going to have 2 positive and 2 negative values. You'll have 2 positive that are between 0 and 360, and 2 negative that are between 0 and negative 360. This one worked out great because the first value was on the greater end. With part B, I give you something that won't work out that way. So let's see how this one works. The first, to label it the most simple way, is I'm just going to observe how many circles out towards pi over 6 is this. It's on the 1, 2, 3, 4th circle. So I would label this point T here as T is 4 circles towards pi over 6. Now because this is in radians, I'm not going to add and subtract by 180 this time. I'm going to add and subtract by pi. So I'll start by subtracting pi. Because this is a fraction, I need to subtract by a common denominator. So if the denominator needs to be 6, I need to subtract by 6 pi over 6, because 6 divided by 6 is 1. So I'm actually going to subtract by 6 pi over 6 here. This gives me my second point. Remember, your R value is going to change from positive to negative, because I'm changing directions. 1 pi over 6 minus 6 pi over 6 is negative 5 pi over 6. That's our second point. And I'm just going to continue on. The third point, I would do the same thing one more time. I'm going to subtract 6 pi over 6. And we'll get that T is now the negative 4 changes to a positive 4. Negative 5 pi over 6 minus 6 pi over 6 is negative 11 pi over 6. This is our third point. Now, as I observe something different this time, I already have my two negative values. That is almost negative 2 pi. That's the limit here. I've got to be less than, or greater than, rather, negative 2 pi. I'm almost at that. So instead of subtracting another pi over 6, I'm going to go back to the very start and say, oh, the fourth one, I must need to add 6 pi over 6. So I've already done the subtracting, and I've got to my limit. I have my two negatives. So I'm going to create another positive one by going up here, and this time I'm going to add 6 pi over 6. And so I'm going to kind of work upward. And so my fourth point, I come back here, and I want to work this way. And so 1 pi over 6 plus 6 pi over 6 is 7 pi over 6. And the positive 4 changes to a negative 4. Now I'm going to check that last one just to kind of explain it. This says go 4 circles away from 7 pi over 6. Here's 7 pi over 6. That means from the origin, instead of going towards it, I go away from it 4 circles. 1, 2, 3, 4. And yep, that is in fact correct. So we did do it correctly. This is the 4 ways to write it. Now I have one for you to try.